What is an inflection point? The inflection point is the point of the function where the graph changes concavity. Suppose f double prime is defined on both sides at a point P. If f double prime is 0 or undefined at P, then P is a possible inflection point. To test whether P is an inflection point, check whether f prime changes sign at P. So here's the point of inflection. We have concave up, and then we have concave down. This is concave down, inflection point, and it's concave up. So we want to find the inflection points of this function. F of x is equal to x to the fourth plus x cubed minus 3x squared plus 2. And we want to find the inflection points by taking the second derivative. So if we take the first derivative, 3 times 4 is 12, x squared. 3 times 2 is 6, x minus 6. We can factor out a 6 and get this. If you get this quadratic, using the quadratic formula, we factor it and we get these values. Another way to do this would be to plug the second derivative into the calculator, find the points at which it crosses the x-axis, and those values are exactly the same as this. So you would plug in y1 to be 6 times x squared plus x minus 1, and then y2 would be equal to 0, and you find the points of intersection like we did before. The points of intersection, find the actual point on the graph of the original function where concavity changes. So you plug those values in and you find the point at which the graph, or where the graph changes. So go to y equals, and here is the function. There are critical points, and I did not put the second derivative in, but here we have concave up, and then right in here it's going to change concavity to concave down, and then it's going to change to concave up. Okay, so there are 2 points, or 2 inflection points. One is at negative 1.61803, and the other is 0.618034. And you plug these values into your original function, and you get these values. Use the first derivative to find the critical points, and the second derivative to find all inflection points. Okay, so the first thing we'll do is find the first derivative, and then use quadratic to find the points. And here we have 2 and negative 1 are our critical points. And draw a number line just like we did earlier to find the local max or min. In this case, if we use negative 2, which is to the left of negative 1, negative 2 minus 2 is a negative, negative 2 plus 1 is a negative, so a negative times a negative equals a positive. Same is true for 0. If I plug in 0, 0 minus 2 is negative, 0 plus 1 is positive, and you multiply those, you get a negative. So what do you think is happening there? And at 3, to the right of 2, 3 minus 2 is positive, 3 plus 1 is positive, positive times positive is positive. So our conclusion is we have a local maximum at x is negative 1 and a local minimum at x is equal to 2. Now, to find the inflection point, let's take the second derivative. So we take our first derivative and we find the second derivative. So 2 times 1/2 is 1, x to the first power minus 1/2. So here is my second derivative. X minus 1/2 is equal to 0 when x is equal to 1/2, or 0.5. So I put 0.5 in there. And 0 is to the left of it. When I plug in 0, I get a negative. So I'm traveling downward. My slopes are negative. And then when I plug in 1, 1 minus 1/2 is positive, so I have my slopes traveling that direction, which tells me that I have a negative and then I have a positive, so therefore there's a concavity change, an inflection point at x is equal to 1/2 or 0.5.